Okay, so we have a question from IMAT. Yes, please read the question.
A simple pendulum is moved from Earth to the Moon, where gravity is 1/6 as strong.
Mhm.
If the period on Earth is 2 seconds, what is the period on the Moon?
Um, so a pendulum moved from Earth to Moon. So this is a pendulum. So we have some pendulum. This is like a pendulum. And the forces here are mg because g is like, gravity of Earth. Let's call it g Earth.
Yeah,
And pendulum on the Moon will also move the same, but he will have another mg, which is mg Moon. The period is connected.
yeah.
T, let's see, T is connected by two things. By the
Length?
gravity, yeah, by the gravity. As much more gravity, the period will be shorter because it's hard to move left and right.
Yeah,
It will be pulled down by the sinus, mg sinus alpha. So it's more hard. And as much more long the pendulum wires are, so of course it will be a bigger arc, a bigger period time. Here
yeah,
t is the period time. So what is the gravity is 1/6 as strong on the Moon. Yeah.
yeah,
So it should be something like the square root of 1 on 6, which is the square root 1 on the square root of 6. How much is square root of 6? 2 multiplied by 2, it is 4. And 3 multiplied by 3, it is 9. So 2.5 multiplied by 2. 2.5 multiplied by 2 is like 5. So this is around 6. Yeah. You know,
yeah.
this is around 6. So it should be 2.5. What we have here?
The answer is A, but it's
Wait. The period on Earth is 2 seconds. So 2 seconds, you multiply it by 2.5. And this will be 5 seconds.
exactly, yeah, it's five
Yeah.
seconds. I don't know why they put the answer as A. Think
4.
something is wrong.
We can calculate it like, exactly and see how much exactly it should be. 1 minute. So if we calculate exactly, which is um, mm, 6 square, 2.45 multiplied by 2 is 4.9. No, it's 5.
It's five, yeah.
Yeah, 5. No problem.
Yeah, yeah.
Yeah. So 1 second. Okay, so
Okay.
we'll solve 2016 IMAT, please. First question, physics. Yes, please.
Which physical quantity can be measured in joules per meter? Is it force? Force.
Okay, let's solve it all. Kinetic energy, this is joules,
Yes.
energy. Momentum, um, so the momentum is the mass multiplied by velocity. So it will be which one? Mass multiplied by. So we know that. So this is mass multiplied by second on meter. This is kilogram.
Yeah.
Yeah. But joule joule is how is joule is connected to kilogram and meters. Joules are actually kilogram meter square s square. So is equal to measure joules per meter. So if you make joules per meter, it would be kilogram meter second square. And this is kilogram meter second. Okay? So momentum is not joule per meter. Yeah, momentum is joule per meter per second. So it's like not correct. This is not correct. And kinetic energy is joule. It is not joule per meter. Yes. Next, power.
Yeah.
What do you think?
No, it's not measured in joules per meter.
So power is force to meter, right? Power. What is power? Work
Work by time.
by time. Yes. 1 second. Okay, so power is work per time. Yeah. Actually, what we are looking for, joules per meter. Joules per meter. What is it? If you take f- uh, if you take work is force by distance. Like how
Yeah.
much force you times distance, how much force you applied on how much
Yeah, you
distance.
exert over
Yeah,
distance.
this is joule, this is Newton, this is meter. So joule divided by meter, this is Newton as you said, which is force, this is work by distance. Okay, so joule by meter, you can also find it by Newton. Let's continue. Power. What is power?
So it's not joule.
Yeah, power is not force, let's
Joule
say,
per
yeah?
meter.
Power
Joule
is
per
joules per second.
yeah.
So it's not true. Okay, work. Actually, work is what we are looking for, right?
Per meter.
Ah, no, work is joule. We are looking for force. So work is a joule. And if you want joule per meter, which is Newton, it would be a force.
Yeah.
Yeah? Okay, cool. Next. So if you want to say multiply, you say times. If you want to say divide, you say pair. Physics. This one. I think they have Turkey here moment in this exam. Not this question, the other one, the after it. Okay, let's
A
go.
student has three 6-ohm resistors that can be connected together in any configuration. What are the maximum and minimum resistance that can be obtained by using one or more of these three resistors? Okay. Assume the connections between the resistors have negligible resistance. The temperature of the resistors is constant. The resistors are used in a DC circuit, and none of the resistors is
DC.
short. Yes.
Okay, so actually let's take two options and remember the, how to say, the rules. If they are in a series, we know that resistance act by summary, yeah? So in this case, you have 6 plus 6 three times, it's 18 ohm. And if
Mm.
you put them in a, how you say, parallel, yeah?
Yeah.
So it's not like this because it should be 1 divided by R equals total, yeah? It is first, second, and third, something like this. So you have 3 divided by 6,
Which
which
is
is
half.
2. So actually the total will be half. So if you want the maximum, the maximum and the minimum they are looking for here, yeah?
Yeah.
It's A. So the maximum is in series, like this, 1, 2, 3. This is series, and this is parallel. 1, 2, 3. Okay, this is a simple one. By the way, it's maybe we should remember also that the capacitors act oppositely. So if you have capacitors in series, they are 1 divided by, and capacitors in parallel, just add them. Okay?
Yeah.
Yeah.
Mhm.
Next question.
And this is a turquoise, I think.
Maybe, yeah,
Turquoise.
let's see. Moment. Yeah, let's see.
Yeah.
The diagram shows.
A uniform horizontal beam of negligible mass, 5 meters long, placed on two supports, one at each end. It has a 300 Newton weight placed at 1 meter from one end and a 500 Newton weight placed 1 meter from the other end. Both weights act vertically on the beam as shown in the diagram. What are the upward forces from the two supports acting on the beam?
Okay. So this is the first weight here. I don't know if you see this. Let's see, laser. So this is here 500. The support is on this point here and this point here. This is the 2 points of support. They will feel the force pushing on them. Okay, so the two weights are one here in a distance of 1 meter and 300 here in a distance of 1 meter. You have total 5, so this is 3.
Yeah.
Okay, so let's see. What is the question? Both ways, what is the question? What are the upward forces from two supports acting to the beam? So the question is, what is the force on this here? So moment, what is it?
Force
Force
multiply,
multiply by the distance, yeah?
yes, by R.
Okay, so we have here 500 multiplied by 1 plus 300 multiplied by 4. How much is it?
Um, it's gonna be 1,700.
3, this is 1,700. Okay. But this is 2 points. So 1 second. So the momentum,
Moment.
moment, sorry, yes, you are right. Turquoise. 500 multiplied by 1 and 300 multiplied by 4. What is it? I will tell you what it is. So this is um, if this is like some axis or some wall, so you have 500 multiplied by 1 and 300 pushing down multiplied by 4. This is the power, the moment pushing this beam down. Okay? Who will feel it? Who will feel it is this holder. Okay?
Mhm.
So you want to compare this moment on what the holder feel. But what the holder feel, he feel this turquoise or this moment in a distance of 5 meters from the axis. So what to do? So you say like this. The moment is 1700. And the moment what this holder feel is some force multiplied by 5 meters. So you
Mhm.
say like this. The force, which is the weight, you want the weight, you want the force, yeah? So the
Mhm.
force, which is pushing 5 meters from the axis on the left weight, equals 500 newtons in distance of 1 meter from the axis, plus 300 newton multiplied by 4 meters from the axis. So this force is actually 1700 divided by 5. I think it's 340 newtons.
Mhm.
Okay, so if you take the other side, how it sees the view from the other side, so it's all flipped, and this is the axis now. And what this holder feels, it's like this. So what the holder on the right feel, F. This F is 5 meters from the new axis. And the moment on this point is 300 Newton from 1 meter from the axis plus 500 Newton for 4 meters from the axis, which is 2,300. So the force is 2,300 divided by 5. This is 460 Newton. So this is the right side and this is the left side.
Yeah.
So when you want to calculate the force, you need to compare moment, not forces. You need to compare moments. So you need also to take in consideration this 5 here. So
Yeah.
the moment on the holder, this is 1700, not the force, the moment. But he's asking about the upward force. So you need to divide, yeah, you need to calculate it from
By
the
the
moment,
distance.
divide by the distance, yeah, because it's the moment that it is 1700, not
Mm-hmm.
the
Yeah.
force. So
Yeah.
if you want the force, you need to divide by 5. So the answer is A.
A. Mm-hmm.
Great. Next. So yeah, they have moment questions.
Yeah.
Okay, so next question. Yeah.
Okay. A ball is projected vertically upwards and then falls back to its original position.
Mm-hmm.
Once projected, the
Mm-hmm.
ball experiences only a single force, downwards,
Yeah.
due to a constant gravitational field strength of 10 newtons per kilogram.
Yeah.
Here are 3 statements about the ball.
Mm-hmm.
1, when the
Wait,
ball...
before the statement. So you have like a
Oh,
ball projected vertically upwards. So of course it will go up and down. The acceleration will always be minus g. The force will always be, actually, no, it's not true. So depend how you look at it. So if you take positive is up, so yes, the acceleration vector will be always minus g. The force vector will be always minus mg. The speed will be 0 here, yeah? And the speed in the beginning will be equal in the speed in the end. I think this is everything. The height, how much high it will go, it depends on the initial speed. Okay, let's see the statements. Okay,
yeah. When the ball is moving upwards, it loses kinetic energy and gains potential energy.
correct. If
Yeah.
Down, it's a half mv square because the v is high and the v goes down until it will reach mgh only because the h will go up. So
Yeah.
yeah, in the begin in the middle, like for example, you will have half of the v and half of the h. So first one is correct. This is kinetic energy and this is potential energy. Yes.
Yeah.
Two,
The magnitude of the ball's acceleration increases as it falls.
magnitude. So the acceleration is always constant. It's minus g, so this is not correct. The
Mhm.
acceleration doesn't increase. Next.
Yeah. No vertical forces act on the ball when it is at its maximum height.
Yeah, the force also doesn't change. It's always minus mg. So it's not correct statement. What you don't have in the maximum height, it's speed. Just speed.
Yeah.
It's zero. So the answer is one only. E.
Yeah.
No, yeah, one only. Okay. Next. So next is we are moving to the mathematics. We finished the math, the physics. So let's go. Next question. Yeah,
Okay. A right angle triangle has an
right,
area of
right angled triangle. Yeah,
18 centimeters meter square. One of the two shorter sides is twice the length of the other one. What is the
one
length?
of the two shorter sides, which is these two sides,
Yeah.
is what? Twice the length of the other one. So, for example, if
Yeah.
this is A, this is 2A.
Yeah.
Yeah, okay.
What is the length of the hypotenuse of the triangle?
Okay, so we know about 1, 2, yeah? You remember 1, 2?
Yeah.
So, like we can solve it, yeah?
We can.
Yeah, we can solve it. Like, let's solve it. So this is like A square plus 2A square square root. So you have A square plus 4A square, which is 5A square square root, which
Mhm.
is square root of 5A. Sorry.
And they gave us the area.
We need to what? What to do? What we need to do?
We need to find the length
To find
according
it.
to the question,
To find it.
according to the answers.
So, okay. So we didn't calculate the A actually in the beginning. We should calculate the A.
Yeah.
So A is A square, which is like A multiplied by 2A divided by 2, right? It's like A
Mm.
square. Yeah? It's
Yeah.
18. So A is actually how much? Square root of 18. What is the square root of 18? Use the primer factorization, yeah?
Mhm.
So 18 is 2 times 9. So it's square root of 2 multiplied by 3. Yeah?
Yeah.
So let's calculate now A. So square root of 5 multiplied by square root of 2 multiplied by 3. So I guess this one. No? Yeah. Why? Because 5 multiplied by 2 is 10. Yeah?
Yeah. What is the answer?
Here. 3 square root of 10.
Yeah, I
Again.
mean in the
You
answer.
want to check? It's question 53C. Yes, correct.
Yeah.
Yeah, but we need to remember about Pythagoras that instead of using all this, calculating each time, we need to remember 1, 2, square root of 5, at least 3, 4,
4, 5.
5, and etc. We had, few to remember. 11,
5,
12,
12,
23,
13.
24. Yeah.
Yeah,
Okay. This is an easy one. Next question.
that's good.
Mhm. Yeah, in this question, by the way, I nearly forgot that, need to calculate A, but actually there's no A here, so it's not a problem. But sometimes they have what is called halfway solutions.
Yeah.
And, the ego is so happy, so sometimes they choose it. They, like, student can choose halfway solutions. Okay, what is this?
Well, we need to simplify.
Which is the following simplified? Yeah, so you remember we did it a lot, this.
Yeah.
So let's remember. We have A plus B square. We have A minus B square. And we have A plus A minus, right?
Mm-hmm.
So I don't want even to write them, Okay, let's rewrite just this one. Yeah. So let's use the third one. The first two we know, yes? A square B square plus 2 times AB, and this is minus 2 times AB.
Mm-hmm.
So usually in these questions, you need to use the third one. So for example, x square minus 1, it's like 1 square, yeah?
Yeah.
So x square minus 1 square, this is actually x plus 1 multiplied by x minus 1.
Yeah.
So you can make a common denominator.
Mm-hmm.
And what we will have here, we'll have 2 minus 1, but the 1 don't have, so it's like 1 multiplied by x plus 1. Yeah?
Yeah.
So this is 2 minus x minus 1, which is how much? 1 minus x, correct?
Mm-hmm.
Or better to say, because you can see it already, you can say minus x. Anyway, I will like just write it like this, okay? Minus x plus 1, yeah? X minus 1. So what you can do here is take the minus outside, it would be x minus 1. And so it's minus 1 x plus
Yeah.
1. Okay, this is also important to remember. Next. Yes.
The straight line graph given by the equation right here intersects the x-axis at A0, and the y-axis at B, 0B. A
So this is
circle.
so this is
Oh,
A
there's a circle.
and this is B. Yeah.
A circle passes through A and B and has a diameter AB. What
So
are the coordinates of the
wait.
center of the circle?
Okay, so there's a circle which like goes something like this, yeah? And this is the center of the circle. Okay, and what also?
We have the equation that is given to us. Mm.
X, yeah. So we have this equation. Straight line graph given by the equation. Yeah, this is a line. So this is a line going like this. Yeah.
Mhm.
Okay, so we'll calculate A and B and find the circle, no?
Yeah.
So this is the plan. Let's go. So for number one, let's calculate a and b. So if x is 0, what is y? And if y is 0, what is x? So you have 0 divided by 4 equals y divided by 6 equals 1. So in this case, which is b, I can write it b immediately, yeah? So b equals 6.
Mhm.
And if I put a here, which is when y is 0, it means that a equals 4. And this is 4. Yeah?
Yeah.
So if you have a circle which is x square plus y square equals r square, yeah?
Yeah.
But this is a circle which is in the center, yeah?
Yeah.
So what we need, circle um, which is not in center.
Well, they asked for the coordinates of the center of the circle.
Yeah. So the coordinates of the center of the circle should be like x minus u, let's say, square plus y minus v square equals radius we know, we don't know also, yeah?
No.
We don't know the radius. But I think the circle, we are the coordinate of the center of the circle. Circle passes through. Okay, so we don't know the radius also. So this is the equation. What we have here, we have 2 points. We have 2 points. If we will, we don't have extra information here. Diameter of AB. This is a missing one, yeah?
Yeah.
Diameter of AB. So the radius, how much is it? AB divided by 2, right? What is AB?
Maybe the points.
That passes through AB and has a diameter of AB. Diameter of AB. AB is the diameter. The circle passes. No, no, we didn't understand the question. Wait. Let me. So diameter is AB, the 2 points AB. So actually the circle is like this. Yeah, this is the diameter. AB is the diameter. Yeah?
Right. Yeah.
Okay. So um, it's the middle point. No need to find anything in the circle. We can
Yeah.
find it. Will give us the answer how you started, but it's more easy. So the point here, the middle, is just A divided by 2, B divided by 2. Yeah, okay?
Yeah.
So this is like 2.3. Yeah? But if
Yeah.
you would solve by the equation we gave before, which is x minus u square plus y minus v square equals AB, what you need to calculate AB, which is 4 square plus 6 square. You need to calculate here some Pythagoras,
Mm.
This would be like 4 square plus 6 square. And this is diameter, so you need to divide it by 2. It will give you the same answer. If you will put the 2 points, but no need for this. It's like more easy, more simple
Yeah.
question. So the diameter, this is what is missing. So it's the middle point. Okay, let's check the answer, Rust. It is 56A here. Next question. Okay. It was confusing here. Big A and big B. This is the point name. A is the point name. The capital A is the point name. The small a is the coordinate of x of the point,
Yeah.
The x coordinate. This was confusing. the capital and the small.
Okay, scientific notation.
Hmm?
We need to solve a scientific notation here in this question.
Okay, let's read the question. X equals, yeah, maybe to read it.
3 multiplied by 10 to the power of m, and y equals 5 multiplied by 10 to the power of n, where
So-
m and n are integers.
Okay, so number one, yeah, of course. So we can think about it also that there's 3 and m zeros behind it, yeah? And 2
Yeah.
and 5, sorry, not so 5. And 5 and n zeros, yeah? Because, what is an integer?
It's a
Yeah, this is in the case that m and n are positive, but it's an integer. Integer is like can be 0 also. And
yeah.
can be negative. So if it's negative, it's how many zeros on the left side, and how
Yeah.
many zeros on the left side of this. Of course, if it's 0, so it's like just 3 and 5. Okay, so yeah, what's the question?
Which of
Multiplication?
the following is an expression? Yeah,
No,
in
but we know this
scientific.
is easy. Multiplication, this is 3 multiplied by 10m multiplied by 5, 10n. So it should be what? 3 and 5, how much?
15.
15. And 10n plus m. But you can play with the 15 because 15 is 1.5 multiplied by 10. Yeah?
Yeah.
And this 10 have a 1 here. So this one, the same one, you can write it 1.5 multiplied by 10 and just add a 1 here. Yeah? Correct?
Mm-hmm.
Which would give us
E.
E. Yeah. Right?
Yeah.
And not C. Yeah, because C
Is a
have
minus.
here -1, so it's not correct. Okay, nice. Small trick question.